So we're going to talk about background jobs in Node and how basically everything you do in Node is better than any other language, except for the terrible ideas, which will be far worse. So all the ideas, there's a repo that goes along with this talk. Feel free to try it out, explore at home. Just like, don't blame me when your production servers catch on fire. So yeah, everything is better in Node, including the bad ideas. So for the point of this talk, we're going to talk about a hypothetical situation, which maybe you've come up with. Someone comes to your website, they sign up, you write a record to the database, and then you want to send them some sort of email, like a welcome email or something, and then kind of respond to the client with a 200 OK, and life goes on and everybody's happy. So there's a couple of strategies for how to do this. We're going to go through some of them today. So you can do it foreground, like inline. You could do it parallel. You could like break out to another thread or process and handle this. You could fork. You could have like a whole other running Node instance to handle emails. You could have like a queue system. Like you could write it to a database that somebody gets to later. And there's other stuff we're just not going to talk about for time reasons. But there's lots of strategies that you could do here to make this email get to the client. And again, they're all like way better in Node than other languages. So we'll start with the foreground. This is still on the PHP homepage as an example. I checked it maybe a week ago. So I started programming with PHP, and of course, like everything's in line, everything's a script, and it's really easy to do stuff. But in this classic example, what happens here, that mail line blocks the request thread. So like you hit the web page, it's going along, like you wait, SMTP stuff happens, like socket things happen, it comes back and it moves on. So the client is actually waiting for like a while for this to happen. So how do we do this in Node? So we're going to use the Node Mailer NPM module, which is awesome. It's really easy to send email really quick. They have all these different transports, Gmail being one of the easiest ones to use, but there's also SMTP and some other layers you can use. So for all of our examples, we're going to use Node Mailer, which provides kind of an asynchronous send message command, which we can use. So stealing code almost directly from the Node website, we can build a web server. And this is the most dangerous web server you'll ever see, by the way. Every request will send an email. So like, again, don't do this at home. Don't do this in production, right? So you see at the bottom there, so like the path is going to be our mail information, like to subject message. And we're going to take the body, and we're going to parse it, and we're just going to split on slashes and kind of make our email this way. So this is really terrible, really bad idea, but it kind of gets the point across. And then this transporter send is from Node Mailer, and this is how we have send the email, and it's asynchronous. So if you run this, which I'll run over here. So in this tab, I'll start up the Node example. So we're going to start our foreground, and it says, here we go. Here's how we use this, port 8080. So if I do like this, so I'll send myself an email, subject will be SFNode lecture, body stuff goes here. So we'll send that, and like we'll count like 1 second. So it was like 1.5 seconds to actually send the email. So that took how long it took to do the Node actual web server part and SMTP the email out. And like in theory, like there we go, I got an email. Awesome, right? Done. Talk out. Okay, cool. So like that worked. Everything's great. So it's better in Node than other languages because at least you're not pissing anybody else off when you do that. With the PHP example and an equivalent Ruby example, you would be blocking a web worker, whatever that means in your language. So like the time it took to send that email, like nobody else could use that request. But at least in Node, because it's all asynchronous, other people can still be making requests and other people can still be getting stuff done, even if the client still had to wait that 1.5 seconds, which isn't that terrible. But when I did this on my couch, it was at least 2, and I could imagine it being worse. So again, it's better than most places, but it's still bad. Like you're still spending server resources. Like maybe I don't want to race the RAM to load in Node Mailer in my process. Like, and eventually there's a lot of socket stuff going on in the background, and bad things could and will happen if a lot of clients are sending these emails. Especially in my example, again, that's terribly unsafe. Don't ever do that in production. So let's go with the next one. So what's the next way we can do this? I have a note to myself. We're not going to talk about like actual threads here. That's a dangerous topic, especially in Node. But what can you do to kind of like pass on the work of sending the email to another background thing? Can't use the word thread. So what that means in Node is you can just ignore the callback. Like that is a thing you can do. It is not recommended. Again, don't ever do this, but it's allowed. Like you can do this. So in our previous example, the only change is to wrap the asynchronous callback in something that just doesn't care. Like if you don't give me a callback, just don't do it. So the web server block is now just send the email. Just do it. Don't care. So if I run the second server here, So let's kill the first one, start up example 2. So it's again the same API, and I can do the exact same thing. And I'm going to get my response, my body payload, like stupidly fast. I have no data to send back because I'm not sure if the email like worked or anything happened. But the client's done, and like maybe I got a new email. I did, awesome. And so as far as the client's concerned, like that kind of worked. But again, like things can go wrong. Like maybe the SMTP server isn't there. Like it's a terrible idea, don't do it. But it's a way to speed up the client response. And so it's fascinating in Node and JavaScript and a couple of asynchronous frameworks. It's very rare you can actually do this. Like you can kind of split the thread off and not worry about ever collecting it again. It's just a unique property of Node. And again, don't ever do this. We're moving on. Never talk about it again. But it's a neat property of JavaScript that you could handle tasks this way. Maybe if you're logging, like maybe it's OK. Like maybe if the callback logged, if it didn't work, like maybe that's a little better. But if you're going to log it anyway, like maybe there's a more elaborate system you could do to handle these jobs. So let's go to the next one. So this is the most over-engineered example possible here. Node has the notion of cluster. So the Node cluster API is experimental, but it has been experimental for some time. It's fairly stable. People use it. And it makes it really easy to kind of take one process and fork out other processes and leave a communication channel up between them. So the little wireframe, for example, here is we're going to have one master process we start, and it has 2 children. It has a web server child and an email sending child, and they can all communicate through the master process and kind of pass information around. So this is our main logic block. There's a really easy way to tell if you are the master, and you do some master stuff. And then you can tech environment variables. So when you fork, one of the few things you can pass to your children in Node is you can pass environment variables. So we'll pass an environment variable called role, and it'll tell the child to either be a server or a worker. And this is how they'll know what to do. So we'll change our web server block here. So instead of saying node mailer directly, we're going to say process.send. So this is in the cluster world. Process.send means if I'm a child, tell my master something. And you can tell the master JSON blocks. So what we're going to say here is we're going to send that email block to the parent, and we can still respond to the client really quickly and just pass that information along. So it's like ignoring the callback, but at least the data went somewhere, and we can log it, and we can handle it, and error catch it, and do other things with it. So let's move on to the master loop. So we're going to have a master process, which is just going to boot up, and every second, every 1,000 milliseconds, it'll just check on its children. And what that means is that we can just do the fork thing. So if you look here, this is the magic right here, cluster fork. So we say, hey, take myself, take the script I'm running, make a new version of myself, and then pass these environment variables down. So what's role server? And everything else here is really just checking on the state of the child. So it's an event emitter. So when the child's online, log it. If the child dies, like delete it from myself. And if I get a message from the child, so here's where the web server would pass on that email information. What did I get? Well, I got this JSON blob about message. Then I can take it, because I'm the master, and then pass it to the other child. I can pass it to the worker to then send the email. And the same thing is very similar for the email worker. We're just going to watch it. We're going to give it a new role and move on. So I'll show you what this looks like when it's running. So let's start example 3 here. So here, we're going to start logging the PIDs. So we have one master worker here. He started up, and he tried to start his children. And he has 2 children, the web server guy and the worker guy. And they both came back with messages. And this is how you can see that one's here. So we can log the PID, log the state, things like that. And again, there's a GitHub repo with all this code we can look at later. This whole example, I think, is only like 130 lines. So in 130 lines, which is really cool, you get all this stuff. So here's the email worker in its entirety. You can get a message queue, throttling, retries, all this kind of fancier logic with this type of build process. So what the email worker child does is every time he gets a message, so process on message, he just adds it to an array. Store the messages, do something with them later. And he has kind of a main loop, and he'll run it every so often. He'll pop one email out of his array. So this is throttling, right? So like every second pop if I have one. So if there's a lot of emails coming to him, like he'll just store them up for later, assuming the process doesn't crash or anything terrible, and then send them all one by one later. So it's a little bit better than being able to hammer that web API like I had earlier, and I could send 1 million emails. At least I'm only going to send one every second. Slightly better now. We can do some retry logic, like if there's an error when I try to send email, like I can re-enqueue it, like put it back in the array. Now I have retry logic. I can send messages back up to the parent, like, hey, it worked, hey, it didn't work. So let's give it a whirl. Because we're using AirPlay, I was actually going to turn off Wi-Fi and show you guys like how retrying worked, but that's not going to work. But again, it's the same API, so I'll just do this again. So now I still get my response really, really quickly. And then like eventually, sometime later, I'll get the email. So this is the response on the web server. Then the worker eventually was like, oh, I'm going to try to send this email. And then eventually you sent the email. I probably should have put timestamps on that. And it was about a second later. So that's really cool. So like in Node, this forking thing, this cluster thing, even though it's an experimental API, is really powerful. This message processing passage thing is really not available in many other languages, at least with this easy of an API to use. It's an awesome way to kind of do stuff like this and get kind of this functionality out of it. So like, it's awesome. So now we have queuing, we have retrying, we have IPC. I can kill any of those worker processes and they'll be restarted. If I kill the web server, eventually come back, but the email worker will still be rerunning, and vice versa, because they are truly different PIDs and different processes. They won't share RAM, they won't share resources. If you had like 2 CPUs maybe on a machine, they could each be using a CPU. You get a lot better. So what's bad here now is it's still only on one host. Like the cluster module only works on one physical server. It has to be able to talk, to whatever else is on the server. But we're getting better, right? So now we're getting retry logic, we're getting logging, we're getting lots of other stuff that we didn't have before. So we're building it up. We're getting a little further into the realm of possibility to use on production. So let's talk about remote queues. So the key piece of the previous example was having this email queue, right? Having a queue of things to do that could be worked at a later time that was really asynchronous into like a whole different thread than the guy hitting the web servers. So the important things about a good queue, let's take a little sidebar here. So like things that are good about queues, they're observable, you can measure them, you can see like what's in there, you can retry them. Even in our previous like terrible example, we put emails back in the queue if they failed, which is an awesome like feature that we didn't have before. So like a quick note, for this example, we're gonna use Redis. How many people have heard of or have used Redis? Has anyone not heard of Redis? Okay, cool. So Redis is a very tiny C++ app, I think, that is basically a in-memory data store. It's like somewhere between Memcache and like a relational database. So it has much fancier data structures, including an array, which is really all you need to make a queue. This is the MVP for a queue. I can put things into the array, I can like wait a while, and I can pop things out of the array, and I'm guaranteed that when I pop, I only really get it once. And I guess that's it. That's all you really need for this queue. Redis has some other stuff, like hashes and sorted sets and fancier data structures. But to do this kind of asynchronous array thing, like you really just need array. So we're going to talk about a module called Node Resque, which we use at TaskRabbit. Resque, if you don't know, is kind of a semantic way to describe things that live in Redis. So they're jobs to be processed later. So there's data structures around like, here's a job, here are the arguments. Here's the names of the files they live in, so I can pull them out later. And so Node Resque is a module that just talks to Redis and lets you do things like connect to a queue, and then I can enqueue things for later, like put the job add in the math queue and add the numbers 1 and 2, and those will be processed later by a worker. And Resque has a really nice UI. So here's kind of an example of the data structure. So it has like a Resque namespace, then a queue namespace, and then the email queue would be the name of the queue that it goes under. This is called Redis Commander, by the way. It's another Node app. It's a viewer for Redis. It's pretty great. And then Resque has a UI. So you can, this happens to be the Ruby UI. It's a Ruby and Python and Java and Node ecosystem. Ruby happens to have the coolest UI, so I just picked that one. But it's really, really introspectable. So you can see the name of the queues, how many workers are running, and things like that. So back to our web server. So we have this method, send email. And this does exactly what we did before. It builds up this email payload. It tries to send the email. But now it's in this thing called a jobs hash. So if you notice back up here, when we're talking to Resque, one of the things you pass into it is jobs. So it's a way to kind of say, like, once I get a job of a certain name, what method do I call? What function do I call to handle it? So our jobs hash can just be this, take your data, build this email payload, and then send it off. So if we're in the web worker, instead of doing the process message send, we'll do the queue and queue send. It's a very similar line of code, but the only difference now is before we boot our server, we're going to connect to Redis first. So that's the queue setup line at the bottom down there. And then we just boot it. And then every time we get a message into the web server, we'll enqueue it in Redis and move on. So Redis is really fast. It doesn't actually have to do the SMTP parts of sending the email. So it's a little slower than we had before, but at least it guarantees us persistence now. And it guarantees us this is a database, so other servers can read it and things like that, which is a lot better. So if in Node Resque, it's really simple to start a worker. The 2 lines at the top, it's very similar to starting up the queue. You just pass it the connection details, the name of the queues it's to work, and again, that jobs hash. And then it boots, and you say start, and it just goes on its merry way forever. It's an event emitter, so you have tons of callbacks again. So we can just log stuff if we want. It'll say like the state of what it's doing. Like I'm working, I'm paused, I'm doing some other stuff, I failed, I crashed. You get all these events out of it that you can act on, but really worker work will just keep calling those jobs hash and doing whatever it says. Do one, try again, do one, try again. It'll also sleep if it has nothing to do, and then like wake up in 5 seconds and try again to kind of save some RAM and CPU as it goes. But it's really simple, and that's all it does. But that's fine. Like lots of other languages can do this. Resque is implemented in all these other languages, but like why is it better in Node? That's the whole point of this thing. Like what's better here? So Node is asynchronous, right? Node has this event loop thing. It's only one thread, but it's really awesome at doing things that are, wait and come back. Like go talk to a database, wait for the answer, and then process again. So everybody thinks of this as kind of handling web requests or handling at least socket requests. But many of these background jobs are going to be the same kind of thing, like talk to the database, wait for the answer. Talk to an SMTP server, wait for an answer. Talk to somebody's API, wait for an answer. And it's kind of the exact same thing as with requests. So as long as your jobs are non-blocking, or at least partially non-blocking, you probably can be doing more than one at the same time. And that's kind of the trick here to this Resque stuff. So rather than just having one Resque worker for process like Ruby and Python do in their implementations, in Node, we can do this multi-worker thing. So we can say, like, have at least one processor and up to 100 processors, and be smart somehow about knowing whether I'm allowed to do more or less. So if my CPU is bound, like, don't make any more workers. But if my CPU is free and I'm just like waiting on I/O, you probably can make some more workers and work more jobs. So like, how do you do that? So it's really simple, actually, in theory, to ask if Node is blocked. You have a timer, and you say, hey, set timeout 10 seconds. And if it takes longer than 10 seconds to get your timeout back, you're blocked. So this I stole from a module TJ has called Node Blocked, which is he has exactly that. He has a timer, and he uses the process time, and he waits so many seconds, and if he doesn't get it back, he knows what his delay is. And there's a kind of a buffer, like you have to allow for maybe 10 to 20 milliseconds to let your CPU kind of catch up. But as long as you're within that buffer, you're probably on time. You're probably processing okay. And otherwise, you're blocked. But only this, 15 lines of code here is really all you need to know if your CPU is pegged, the CPU of the Node process. And as long as whatever you're calling is mapped in either a set immediate or a process time, a next tick, you'll be able to make sure that it is called to work when the CPU is free, and you can see how long that takes with this right here. So what you can start doing is you can have a couple examples here. So we're going to have a blocking sleep. So remember, terrible ideas. This is how you block the entire Node CPU while true, just like wait for time to pass. So this will peg the CPU at 100%. It'll just sit there and do nothing until time passes. And the equivalent is the kind of the async sleep with just set timeout, and that does nothing, and that's the freest kind of time where you can wake. So we have these two jobs here to kind of demonstrate this. There's like the slow job, which uses our blocking sleep, and then there's the set timeout job, which is free. Yeah.
What does
pegged mean? Pegged? Pegged is an older term that means so you have the CPU is as used as it can be, right? So you're always doing arithmetic on it. You're always working it. It's when your computer fan starts making weird noises at you. It's like doing complex math as opposed to just waiting. So the event loop is really smart, and I'm not smart enough to understand exactly how it works, but it knows if I'm not doing any I/O right now, I can chill, I can sleep a little bit and come back and check again if there's something for me to do. But if you're saying while true, add 1 or something, the old Fibonacci example, it's always doing math, that will just use your CPU up as much as possible, and no other I/O will get through until that's done. So like if you have one web request that says like, do this blocking sleep for 10 seconds, no other web request will be able to be processed because the CPU is fully used, like fully, claimed. And then once that job is done, then Node will be smart and start processing the next jobs as it goes. That's the term pegged, basically claimed, used, fan spinning. So the whole point of these background jobs is they probably use more CPU than just the web server. And the whole point of splitting these up is that you want to make the web server really responsive and fast to client requests. And you're kind of offloading any job that's tricky to these workers on the side. So it's really possible these workers might be doing CPU-intensive operations, and that's fine, because it's not going to affect the end user as long as you have enough workers and everything. And the whole goal here is kind of to save money, right? So you want to work as many of these jobs as possible if you can. And if you can, it has to do with whether your CPU is free. I think I have only a couple more minutes left, so I won't run the example unless anybody wants to see it. Run it? All right.
Do it.
Run the example. Let's do it. All right. So node 5. So this example we'll do, we're going to enqueue. Here's a little rescue UI. So we're going to check every so often. We have a couple queues here and 0 workers running. So I'll queue like 10 of those high CPU jobs and like 100 just sleep jobs, if I did this right. So here's our queue. We have 1,000 workers, and we're only going to work one at a time. And it's going to work one by one every second. Get down, get down. And then once it realizes the CPU is free, it'll start spinning up more and more of these workers to just kind of sleep, which is the next job. And it'll be smart about going up to the 100 limit that we set. And then once the jobs are done, it'll span back down. And doing this in Node again is as simple as this bit right here, just checking if my CPU is pegged, and and then doing more asynchronous work. So we can like stare at this if you want, but eventually it'll work all the way through and clean itself up. So what we got in Node, it's way better than these other languages because you have, again, in only like 15 lines of code, this amazing way to tell like how much work you're doing in your thread, in your process, which is really new and unique and something to Node. So that's in the Node Resque package now. It's called the multi-worker because I'm great at naming things. And that's a great feature of Node. So I think that's it. So these slides are up, the GitHub project's up so you can play with this stuff. And there's some docs to the Resque project to kind of see how it's implemented. And now we finally have a good way to send email. We have a background job, we have a database to store it in, and we're not like wasting resources in our web server. And hopefully no one will get spammed.